Okay, so wow, it is always, I love the rush getting in front of a bunch of folks who are excited about a topic. So real quick, just wanted to check who's really excited about going to the moon. Come on. All right. All right. Now hold your applause for 1 second, because now I'm going to ask for a round of applause for each other that we made it here. Do it right now. Let's go. Come on. Where have we made it to? Well, I started coming to these things when they were the NLSI, very beginning, working with folks like Greg and a series of leaders who have participated over the years. I was early career at that time, and I will say we have never been closer to the moon than we are right now. Okay, in that whole time, even though we all want to go there and we all want to fly astronauts, we want to fly payloads, we want to do science, we haven't been as close as we are now. Since I've spoken to this community last, we have successfully flown the Artemis 1 mission. You may have noticed that late last year. If you were anywhere in Florida, you saw a big white flash. That was a big rocket, the SLS and the Orion, Space Launch System in Orion, on their way to the moon, out and around the moon, and they came home, and we learned a lot from them, okay? They taught us a lot. Now that puts us in a position for flying a very similar mission, sending our spacecraft around the moon, except this time it's going to have our friends on board, okay? Artemis 2. So we're on track to fly Artemis 2. And I do want to note, I just had breakfast with the early career folks, and you know, it's really important. I'm very deliberate about the fact that I refer to our astronauts as our friends, okay? They are not some people that are in slides or videos, right? They're people many of us know. And if you don't know them, I hope you get a chance to know them. We care about them, we love them, and we're not flying missions until we're ready to make sure that they're coming back, okay? So while I very much appreciate everybody's inquiries about when is Artemis 1 going to launch, the answer is always the same: when we're ready, okay? But because we flew Artemis 1, we're in a very good position to follow our timeline and get Artemis 2 up there. That opens the door for Artemis 3, and I think everyone is quite excited because of the round of applause I just heard. We're going to the moon, right? We're going to send people to the South Polar region of the moon, place no one has ever been before. First, we're going to have the human eyes on the far side of the moon for the first time in 50 some years, right? So we're knocking off, we're hitting a bunch of checklist points here that are very important for this exploration. So I do want everyone to understand where we are right now, okay? Because sometimes I talk with our teams we work with all the time. It's easy in the day-to-day grind to get frustrated and tired and exhausted and irritated, right? But you got to stop for a second, back up, get your head up, and realize where we are and what we're all doing, okay? We're all on the same team, and we are all trying to fly missions to the moon and beyond and learn how to live in space, okay? Which to me is amazing. That's kind of like the awesome sci-fi stuff you watch when you're a kid, right? We should all be excited. So I'm glad that you all gave each other a round of applause, because when you say stuff like that, you're like, oh, I hope they don't not applause. That would be really embarrassing. Okay, let's go on. So thank you for that. I also want to point out, mentioned by both Greg and Christina and just now me, having breakfast with the early career folks. It's tremendous to see such an influx, because I do remember, and just said this to them a few minutes ago, do remember the first NLSI, and there weren't too many people on the early career end of that spectrum. And times it was a little awkward, but we have all worked together, and many of you have supported us to develop that community, because I don't know why we're doing this if we're not doing it to hand that torch off to the next generation. Can't think of a single reason why we'd be doing this. So we need them. We need to nurture and help them mature in this environment so that they're ready to take that torch from us and move forward. So if you were one of the early career people, I want you to put your hand up. Do it. Everybody up here, turn around and look at them, right? That's why you're doing this, okay? So I know the next 3 days, we got really important stuff to talk about with each other, but the most important thing you can be doing is talking to them, right? So if you come talk to me, I'm probably going to say, go talk to them. I don't want to talk to you. No, I won't do that, but maybe I will. That's my little rambling intro here. I hope we're all excited. I hope we all understand the immensity of what we are about to embark on in the next few years. So I always try to figure out what I want to talk about. And, we've gone through a number of reorgs in human exploration in the last few years. In fact, that's kind of the norm. I just get used to it at this point. But we're starting to get ourselves settled out now to go do this job. Okay. When we were told we're going to the South Pole of the Moon, we had an organization that was very much structured to support the International Space Station with a little bit of effort dedicated to thinking about what the next steps might be. We've gone through several reorgs, learning along the way and structuring ourselves correctly so we can go do the job. Continue the work in low Earth orbit, start handing that off to our commercial partners in a more significant way, enabling us to focus on the next step, which is going out to the moon. Okay, all of these things are linked. They're intimately connected with each other. They're activities we need to do together. So we're in a good position now. I'm in, again, whatever trust you have in me, let me say, trust me, I think we're in a pretty good spot right now. We're doing a good job at organizing ourselves. Our directorates are talking to each other regularly. I mean, I talk to Sarah almost hourly at some point. So, and not just like because she's my friend, because we have set up a structure that requires us to talk to each other, because we have to talk to each other so we know how to go do this job that we're being asked to do. So those things are happening. Again, are we frustrated sometimes? Yes. Are we irritated and tired sometimes? Yes. But when you stop and stand up and remember what we're doing, these are the growing pains to get there. Okay, we're learning. Amanda and Nam just said this to the early career folks. Apollo was a great program, and we learned a lot from Apollo, but it is not Artemis. Okay, and so when we're trying to figure out how to do something right now, we can learn from Apollo, but we can't go copy Apollo. So we are learning and making this up as we go. A lot of background and experience to help us do it, but this is all new ground. Okay, so I use that phrase growing pains not lightly. It's really what we're doing. We're learning to work together in an organizational structure within NASA, with our industry partners, with academia, with our international partners. Okay, this is a global endeavor that we're undertaking at this point. Okay, this is not going to be NASA alone, because we know NASA alone isn't going to have the longevity that we all desire. We need the partners. We need to mature these relationships. Now, I start with this slide. Our priorities. You probably have already read it like 3 times while I'm rambling on about other things, but this is where our direction comes from. Human and robotic space exploration missions will land the first person of color on the moon, advance the robust cislunar ecosystem, continue to leverage human presence in low Earth orbit to enable people to live and work safely in space, and prepare for future missions to Mars and beyond. When I say we have a big task ahead of us, that's it. Right? This is the direction we have. And it comes from a series of documents, which you can see at the bottom. One important thing I like to point out is the dates on some of those documents. We have gone through a presidential change and have stayed the course. That's not necessarily something that has been true in the past. Okay, we have industry signing up. We have international partners signing up. We actually have support at the congressional level to keep doing these jobs and moving forward on them. These are all the situation that we're in. We must take advantage of it. It doesn't get much better than this, I don't think. Okay, I'm not sure that it can. But why are we doing it? This is another slide that we've been using when we interact with international partners and our community here in the United States. What are the benefits to humanity of doing this task? Well, why are we exploring? Well, a lot of ways you can slice and dice that. Okay, I think we can all do that. But this is the way that we have organized our thinking about it. We talk about the 3 pillars of exploration, and they're listed right here. Inspiration, national posture, most important, I think, to this community, science. Okay, we're going out there to learn. We have to learn. That's why we're going. The tool we have for learning is science. Okay, science is what will help us learn, which will help us do more exploration. To do more science, to do more exploration. We all know this, right? We have all kinds of great phrases from people far greater than myself who have pointed out this connectivity between science and exploration. But I want you to understand where we as an agency, NASA, are looking when we explain why we're going. And that's these three pillars right here. So we've started also setting up, how do we answer all the questions? Who, what, when, where, why, and how? I'm not going to read through all of this. I want to get these slides into the slide deck so that you can look at them yourselves. But these are the questions we have to answer as we begin to decide how to build the architecture to go do the job. And depending on which of these questions you ask first, you might design a different architecture. And so what ESDMD is doing right now in collaboration with our other directorates, the agency as a whole, is exploring what are the driving objectives and how do we develop an architecture to go meet those objectives. What we're trying to do, you may have heard this phrase, is architect from the right. What that means is, on a chart, for instance, off to the right, we would like to know why we're doing this. What is it you want to accomplish? And then use that moving to the left to decide how to build the architecture, as opposed to maybe our more traditional approach of architecting from the left, where we say, here's a thing that you're going to have. Now tell us how you will use it to go meet your objectives. So we're kind of flipping that around. Over the last 2 years, we've been interacting with the community outside of NASA and inside NASA, globally, here in the States, with our industry partners, again, academia, other agencies, to document the objectives. What is it that your discipline area, that your community wants to accomplish? Those are now captured in what we call the Moon to Mars Objectives document. So you can go look at that. It's a public document. This is where we capture what those objectives are. And then we go through a process of grouping them together. So in the middle, you see 4 sets of objectives that we've identified. Science being one, but also transportation and habitation, lunar and Mars infrastructure, operations. And then we have another group that we call recurring tenets. So some common aspects to the objectives that are present through all 4 of these. So as we group those together, we can then begin to ask the question, to meet an objective, what do I need to be able to do? I need certain capabilities or functions, and I can break those out from the objectives and start looking at the broad set of capabilities and functions that are needed. From there, we can make informed decisions about what's the next element we need to build that actually addresses capabilities and functions across the broadest set of objectives that the stakeholder community has. This is what we mean by architecting from the right. Now, one thing I want you to take away from my presentation is that now that we've gotten ourselves structured and organized fairly well, we are starting to have a set of public documents. We have a document that is public and a process that will also be engaging the community. This document and process are how we need to communicate with NASA to ensure that the things we want to do are captured inside this architecture. I have 2 documents here on the left. Two things on the left. The architecture definition document, ADD. You may start hearing that acronym, so I want to familiarize you all with it. This is about a 150-page document, and the purpose is to give documentation, basically a snapshot of where we stand on our human spaceflight architecture on a yearly cycle. We will update this document every year, and it is the go-to place that you should start when you have a question about the architecture. Okay, this will tell you what our current thinking is. Again, that will be updated every year via a process called the ACR. That is the Architecture Concept Review. So we have a large number of people taking part in a yearly review, trying to understand how to go from the objectives, breaking that down into decisions about the architecture. Each year we do the ACR and we will update the ADD. So get those 2 acronyms in your head. This is a good reference point. We will also be publishing a series of what we call white papers. These are much shorter, 4 to 6 pages long. I believe we have 6 of those right now. And these are generated because we are receiving the exact same question over and over wherever we go. For instance, along with Noah Petro, I helped write one of these white papers this cycle, talking about why we're going to the South Pole. Get asked that question all the time. Here it is in plain English, very simple, explains that. Does it mean you agree with all of it? No. Are you going to get everything you want out of the architecture in an optimized manner for you personally? No. I can say that right away, because we're dealing with a global, diverse set of stakeholders. So what we're trying to do is find the best option to advance for the most of those stakeholders that we can when we make those choices. Another example would be why NRHO, near rectilinear halo orbit. Get asked that every time we go out in public. Why are you going this orbit? It's not the best orbit. It's not a great orbit. It's actually a pretty good orbit when you take into account all of the things we need to take into account. So there it is in plain English, explains kind of what we're doing. We also have a summary of the ADD that's a shorter document on an order of about 20 pages. So we're trying, hopefully you can see, to get information to the community. We don't want to be doing this in isolation behind closed doors, smoky rooms, whatever, phrase you want to say that's kind of negative about making decisions on architectures. We're trying to engage. Yearly, we will engage on the ACR through a series of workshops. We just completed workshops in London and then back here in DC, working with our industry partners and academic partners. We're asking the community for information so that we can update these documents. This is just a QR code to that same set of documents. It'll be in the slide deck. It'll be available. Please go there. Again, familiarize yourself with this information. Okay. First thing almost anyone's going to say to you when you ask a question is go look there. Okay. If you still have questions, let's have a chat. But if one of the first questions we ask at the workshop is who's read the ADD, right? And if you don't have your hand up and you're asking questions, the answer is go read the ADD. Okay. Very simple. So real quick, I borrowed these from Sarah. Science Mission Directorate has a very heavy hand in the science objectives, right? And that's because of this amazing set of documentation. Okay. It's not, again, people in some basement room at headquarters making this stuff up, right? It comes straight out of all of the work that all of you have done. Just to drive that home, here's an example of a few decadal science themes. Some of you in this room had a heavy hand in writing these on the left-hand side of this chart. Those translate into what's on the right side of the chart. Okay, these are the Moon to Mars objectives. These are the drivers for the architecture development that we have underway. Okay, I'm not going to read through it. It'll be in the slide deck. You can take a look. Please go familiarize yourself with this information. This also applies to our human research program. Okay, they have objectives that we need to just learn how to live in space so that we can go do more work. Okay, so I just do want to drive home the point that there's a diverse community of stakeholders that we need to take into account. Real quick, I already mentioned Artemis 1 was successful. We went and we learned about how to fly the SLS and the Orion in an integrated manner. We also learned about how to begin doing science in these missions. Did every single one of these science activities go perfect? No. Did we learn about how to do science so that we can try to do better on our next mission? Absolutely. Okay, that's what we're doing. We're learning exploration science, hand in hand, climbing the ladder towards advancing ourselves and exploring the moon and space. Okay, so we're going to work science into all these missions as we move forward, Artemis 2, Artemis 3, and on. And Artemis 3, that's what we're all going to be super excited about, right? Getting those boot prints back on the moon in the South Polar region, a place no one's ever been. So with that, I'm going to finish here and hand over to Sarah because I don't want to eat up her time like I almost always do. But I do want you to know ADD, Architecture Definition Document, online, very public and available. Be familiar with that acronym and that phrase because it is how we communicate our architecture to the public. ACR, Architecture Concept Review, acronym, name. That is our cycle that we use on a yearly basis to ingest inputs from you all and then drive updates to the ADD on a regular basis. Okay, so walk away from here knowing that. Okay, Sarah, I guess I'll hand off to you now and just let's do this, right? Unprecedented opportunity.